In this first example here, we're going to be taking a look at some dosage calculations that involves an IV. We've got 42 milliliters is ordered to be infused over 1 hour. The drop factor of the IV tubing is 15 drops per milliliter. How many drops per minute should be given to infuse the total amount over 1 hour? So what we're going to do here is we're going to go ahead and start with our drop factor. That's 15 drops per milliliter. So I'm going to do 15 drops. I'm going to put that on top. I'm going to have the 1 milliliter on the bottom because I am going to set this up for unit analysis. So let's go ahead and label this our drop factor. All right, if we're using unit analysis, that means I'm going to multiply by another fraction. I'm going to multiply by what's ordered. I've got 42 milliliters is ordered to be infused over 1 hour. In unit analysis, you want labels to cross off. So since milliliters is in the bottom here, I'm going to put milliliters in the top here. So I'm going to have 42 milliliters, and then I'm going to have 1 hour here. Okay, we're going to label that as what was ordered. Okay, now doing the unit analysis, I've got milliliters in the bottom, I've got milliliters in the top, so those two can cross out. The only two labels I have left are drops per hour. The question asked for how many drops per minute. All right, so right now I've got drops per hour. So I have to do a conversion factor to convert these hours to minutes. Well, we know that there are 60 minutes in 1 hour. If I want my hours to cross off, I've got to put the 1 hour in the top and then the 60 minutes in the bottom. So now I can do this as my conversion factor. And now my hours on the bottom with the hours on the top crosses out. So now if I look, I've got drops per minute. The question says how many drops per minute. So the only two labels I have left will answer the question. So then that means I can go ahead and multiply straight across the top. Using a calculator, you're going to have 15 times that 42 is going to give you 630 drops. And then going across the bottom, you'll have just a 60 and then 60 minutes. When you go ahead and divide 630 by 60, you're going to use a calculator. You're going to get 10.5 drops per minute. All right, but you cannot do a fraction of a drop when you are setting the IV pump. So you are going to always round this up to the nearest whole number. So then this is going to be 11 drops per minute. Okay, for our second example, vancomycin, 1 gram in 250 milliliters, 0.9% NS, normal saline solution, is ordered to be infused over 1.5 hours. The tubing drop factor is 60 drops per milliliter. How many drops per minute should be given to infuse the total amount of vancomycin over 1.5 hours? All right, now in the first example, I used unit analysis and I did 3 conversion factors. I multiplied 3 different things together, and the last one was a conversion factor of 1 hour equals 60 minutes. All right, we know that there's 60 minutes in 1 hour. So if you want to shorten the unit analysis just a little bit, and if you catch it, the question is asking for minutes, and they give you 1.5 hours. All right, however, you can do that pretty easily. All right, we know that 1 1/2 hours is equal to 90 minutes. So if that's the case, and you want to shorten that unit analysis a little bit, when we do the 250 milliliters, instead of doing 1.5 hours, we're going to replace that with 90 minutes, and it just means that we'll be multiplying 2 things in our unit analysis. All right, so just another alternate way that you can be doing this. All right, now I still want to start with my drop factor. Okay, the tubing drop factor is 60 drops per minute, so I'm going to have 60 drops per milliliter, not per minute. I think I said that wrong just a second ago. We got a drop factor here. All right, now I'm going to multiply that by what is ordered, and what was ordered is 250 milliliters to be infused over 1.5 hours. But like I said, we know 1.5 hours is minutes. The question is asking for drops per minute, so I can just go ahead and write this as 250 milliliters per 90 minutes. It's the exact same thing. You're kind of doing that conversion in your head as opposed to in the unit analysis. All right, so this is what is ordered. All right, now at that point, we can take a look and we can see that that milliliter and that milliliter is going to cross out. So we'll use a calculator. 60 times 250 across the top there is going to be 15,000. And it'll be drops because that's the only label that's left up there. We got our 90 minutes in the bottom. Okay, you'll use a calculator. You'll divide 15,000 divided by 90. You'll get a decimal, repeating decimal, 166.6 repeating, so 67 drops per minute. But you can't have any type of fractional drop. So we're going to round to the nearest whole drop, which will be 167 drops per minute. In this third example, we've got the physician orders 3,000 milliliters of lactated Ringer solution, commonly abbreviated with an LR, to infuse over 24 hours. How many milliliters per hour should the IV pump be programmed for? So basically what they're asking for this is you can think of this as a unit rate. They want milliliters per 1 hour. They gave us 3,000 milliliters per 24 hours. So basically, you're just going to come up with that unit rate. Okay, so they said 3,000 milliliters per 24 hours. Okay, so that is what was ordered. Let's go ahead and label that ordered. Now, to get a unit rate just means that whatever is on the bottom is a 1 hour. So how many milliliters per hour? So you're going to take your calculator, you're going to divide 3,000 by 24. That's going to come out to 125. And then your label will be milliliters per hour. So this one is pretty much a straightforward, just calculate a unit rate for whatever is ordered, because chances are whatever's ordered is not in a unit rate. Example 4, the doctor orders vancomycin, 1 gram, IV PB, intravenous piggyback, every 12 hours. The pharmacy sends vancomycin, 1 gram in 200 milliliters, 0.9% NS, to infuse over 90 minutes. Calculate the milliliters per hour. Okay, so we're going to start with what was ordered. All right, so what was ordered was the 200 milliliters in 90 minutes. So we'll have 200 milliliters in 90 minutes. Okay, let's go ahead and label that ordered. We're going to continue with this unit analysis. So then I'm going to need to multiply by a conversion factor. I've got milliliters per minute. I need milliliters per hour. So I've got to get rid of my minutes. We know that there are 60 minutes in an hour. So 6 minutes is on the bottom, so I want my minutes on the top here. So I'm going to do 60 minutes in 1 hour. That's going to let me cross off my minutes and minutes here. This is my conversion factor that I needed to be able to do that. So conversion factor. All right, now I take a look at what I've got. I've got milliliters per hour. It asked me to find milliliters per hour, so that means I'm good. We can multiply straight across the top. That 200 times 60 is going to give me 12,000. Only label in top is milliliters. And then I've just got 90 times 1, so 90 hours on the bottom. You're going to go ahead and divide here, 12,000 by 90, and you're going to get 133.33 milliliters per hour. Example 5. A patient has an order for heparin sodium IV at a rate of 1,100. Concentration is heparin sodium 25,000 units in 25 milliliters D5W. Dextrose 5% in water. At what rate in milliliters per hour should the IV pump be programmed? All right, so we're going to again continue with this unit analysis. We're going to start with what was ordered. So 1,100 units per hour is what was ordered. So I'm going to have 1,100 units per hour. Okay, we're going to go ahead and label that as to what was ordered. Using a unit analysis, I then am going to multiply by the available concentration. My available concentration is this 250 milliliters, 25,000 units. Okay, now again, I'm using unit analysis here, and I'm going to want things to cross off. The only thing that matches is units and units. So I want that 25,000 units in my denominator. I want the 250 milliliters in the top. So I'm going to write 250 milliliters over that 25,000 units. Okay, we're going to label that as our available concentration. And then I can see with my unit analysis that I've got units and I've got units. The units are going to cross out. If I then check my labels, I've got milliliters per hour. That's what they wanted, milliliters per hour. So then I should be good to multiply straight across the top, multiply straight across the bottom. So when I go across the top, I'll have 275,000, and it'll be milliliters there on top. I'll just have the 25,000 on the bottom, which is hours. We'll go ahead and use the calculator, divide those two things out. We will get 11 milliliters per hour. For example 6, we're supposed to administer heparin 500 units per hour continuous IV. The pharmacy supplies the heparin with a concentration of 20,000 units in 500 milliliters D5W, dextrose 5% in water. At what rate should you set the IV pump? Okay, this is going to be pretty much the exact same thing as example 5. We're going to take what was ordered, which is the 500 units per hour. So I'm going to go ahead and put 500 units on the top, and then per hour will be on the bottom, and that is what is ordered. Okay, using the unit analysis method, I'm going to then multiply by my available concentration. It was 500 milliliters, 20,000 units. Again, I want this to set up for my unit analysis so that my units there are going to cross off. So that means I've got to put the 20,000 units in the bottom. And then I've got to put the 500 milliliters in the top. Okay, this is going to be my available concentration. So now looking at what we've got here, I've got a label of units in the top. I've got a label in the units in the bottom. I can cross those out. The only thing left is milliliters per hour. At what rate should you set the IV pump? That is going to be milliliters per hour. So then I can multiply straight across the top, multiply straight across the bottom. When I multiply straight across the top here, I'll have 250,000. Label will be milliliters. On the bottom, I'll just have that 20,000. And that'll be hours. You'll be able to take calculator, divide out. You're going to get a 12.5 milliliters per hour. All right, example 7. You receive shift report that your patient is on a heparin drip and you want to verify the dosage that the patient is receiving. The pump is running at 12.5 milliliters per hour. The label on the bottle reads 20,000 units in 500 milliliters D5W. How many units per hour is the patient receiving? All right, so I'm going to again take what was ordered for the patient, and then since I'm trying to verify and come up with units per hour, I'm going to multiply by the pump rate. So what was ordered was the 20,000 units in 500 milliliters. So I'm going to start with that. 20,000 units over the 500 milliliters. Okay, let's go ahead and label that as what was ordered. Using that unit analysis method, then on this one, I'm going to want to multiply by the pump rate. The pump rate was 12.5 milliliters per hour. Okay, again, if I'm using unit analysis, I'm going to want the milliliters to cross out, because the problem is asking for units per hour. So that means I've got to put the 12.5 milliliters on the top and then the per hour on the bottom. Okay, let's label this as pump rate. Remember what we're multiplying here. Now I'm going to take a look at my unit analysis. I've got milliliters in the top. I've got milliliters in the bottom. Once I cross those out, the only two labels left are units per hour. The question is asking for units per hour. So I'm going to multiply here straight across the top. I'm going to get 250,000, and that's going to be units All right, multiplying there on the bottom, I'm just going to have a 500, and then I'll have hours. When I take that and divide that with the calculator, I'm going to have 500 units per hour. For example 8, your patient's recent PTT is 42. According to protocol, you need to increase the heparin drip by 2 units per kilogram per hour and administer 30 units per kilogram IV bolus. You will recheck the PTT in 6 hours. The patient is currently receiving a heparin drip at 16 units per kilogram per hour from a bag that reads 25,000 units per 250 milliliters. The patient's weight is 163 pounds. How many units will the patient receive as a bolus? And what will you change? Okay, so this question actually has a lot of information. So let's try to highlight and organize some of it here. All right, it tells us that we're going to increase the heparin drip by 2 units per kilogram per hour. All right, it also tells us that we are currently receiving a heparin drip at 16 units per kilogram per hour. All right, so those two pieces of information go together. All right, that means that the new dosage is going to be 16 plus 2 is going to be 18. Okay, so let's go ahead and write all of our information down here. So our new dose, all right, that we're calculating here is going to be 18 units per kilogram per hour. Okay, now the bolus that we need is 30 kilograms, 30 units per kilogram. So that information is right there. Let's highlight that. Then it also says that the bag currently reads 250,000 units per 250 milliliters, and our patient weighs 163 pounds. So those are the other pieces of information. Okay, so one thing at a time. All right, this is going to be something where we're going to have to involve weight. So the very first thing you're going to have to do, you notice that the patient's weight there is in pounds, and everything as far as what we're being given is kilograms. Okay, so the very first thing you need to do is convert the patient's weight to kilograms. All right, so we'll try to organize this out here. So convert patient's weight to kilograms. All right, so from the fall semester, you should remember that pounds to kilograms is just going to be dividing by 2.2. But if we want to stay consistent with this unit analysis, then we're going to go ahead and show that. We'll have the 163 pounds over 1, trying to convert that to kilograms. Then we're going to multiply by our conversion factor of 1 kilogram is equal to 2.2 pounds. Okay, so yes, you have to have this memorized, but like I said, probably at this point you just know you take pounds divided by 2.2. Okay, so your labels do cross off. The unit analysis works. That's going to be a 74.09 kilograms. Okay, so that's something that we are going to have to be using then in some later calculations. Okay, now let's go ahead and do the one where we're going to need this. We've got to, let's see, how many units will the patient receive as a bolus? Okay, so that's one question. And then what will you change the flow rate to? So we'll do first question first here. We've got to calculate the units for the bolus. So we're going to calculate units for the bolus. Okay, so what we're going to do is we're going to start with our 30 units per kilogram. Okay, so 30 units per kilogram. All right, if I'm sticking with this idea of unit analysis, I just need to know how many units the patient's going to receive. Right now, I've got units per kilogram. That should tell you then you've got to use the patient's weight. We're going to do the unit analysis thing. So this weight has got to go on the top, so the weight crosses out, and I'll just be left with my units. So we'll put the 74.09 kilograms on top. We'll put it over 1. That's going to allow us to cross out those kilograms, leaving me with just units. All right, so you'll take 30 times 74.09 on your calculator. You're going to get a 2222.7. We're going to round that to 2,223 units. Okay, so pretty straightforward there. Okay, now we'll do the last part of the question. It says, what will you change the flow rate to? All right, I'm going to go to a new piece of paper. We'll put some of this information that we have highlighted here up in front. Okay, so on this piece of paper, I just already had all the information pulled from the top. Okay, so last part of the question, what will you change the flow rate to? We've got to go to milliliters per hour. Okay, so we're going to be calculating a new flow rate. Calculate new flow rate. All right, so we're going to start with the patient's weight, okay, because we are going to have to use the 18 units per kilogram per hour. Okay, so I know I've got kilograms in there. Kilograms are going to have to cross out because we want just milliliters per hour. So I'm going to start with the patient's weight. We said was 74.09, and that was kilograms. We'll put that over 1. Okay, now I need to multiply by the new dosage, which is the 18 units per kilogram per hour. Okay, the kilograms are on top. I'm going to put the kilograms per hour on the bottom because I want hours on the bottom in my final answer. So I'm going to multiply this by 18 units per kilogram per hour. All right, and then we can see at that point, we can go ahead and cross out the kilograms and kilograms. All right, now the next thing is I need to get rid of the word units. So my conversion factor that I'm going to use is what was the concentration that was available, 25,000 units in 250 milliliters. Okay, the way I will know what to place on top and what to place on bottom, I need units to cross out. That means that the 25,000 units has to go on the bottom, and the 250 milliliters on the top. All right, that's now going to let me cross out units and units. Okay, so now I have milliliters on top, hours on the bottom. What will you change the flow rate to? Milliliters per hour. I've got milliliters per hour, so now I know I'm done. I can multiply straight across the top, multiplying all those numbers. You're going to get 333,405. Label will be milliliters. Across the bottom, the only thing we have is that 25,000, and it's got a label of hours. So I got milliliters per hours. You'll divide those out. You're going to get a 13.3 milliliters per hour. Example 9. The doctor orders your patient to start an IV heparin drip at 18 units per kilogram per hour and to administer a loading bolus dose of 30 units per kilogram IV before initiation of the drip. You're supplied with a heparin bag that reads 25,000 units per 500 milliliters. The patient weighs 172 pounds. What is the flow rate you will set the IV pump at? That'll be milliliters per hour. And how many units will be administered for the IV bolus? All right, so this has got a lot of information in here, so why don't we start this one by highlighting some of the important information. Okay, so what has been ordered here is the IV heparin drip at 18 units per kilogram per hour and the 30 units per kilogram of that bolus. Okay, you're supplied with a heparin bag that reads the 25,000 units per 500 milliliters, so that's important, and your patient weighs 72 pounds. Now, just like in example number 8, we've got pounds here, but yet everywhere in our problem we've got kilograms. So then that should be your first clue. You need to convert those pounds to kilograms. All right, and we know that you're just going to divide by 2.2, but just for the consistency of the unit analysis, we'll go ahead and show it done in that manner. So we're going to convert the patient's weight to kilograms. Okay, so we've got 172 pounds. We'll put that over 1. Using the unit analysis, we would multiply by the conversion rate of 1 kilogram is equal to 2.2 pounds. Okay, that clearly shows you that your pounds on top and your pounds on the bottom cross out, leaving you with kilograms. You'll grab a calculator, do that division, and you'll get a 78.18 kilograms. And then that number we will have to use in our remaining two calculations. All right, what is the flow rate you will set the IV pump at? That's going to be milliliters per hour. And how many units will be administered for the IV bolus? Really doesn't matter which one of those two questions we answer first. I think calculating the units for the bolus will fit nicely here. Calculating that flow rate is going to be a little bit longer, so I'll save that for the bottom of the piece of paper. So we're going to calculate our units for the bolus. All right, so what was ordered was that 30 units per kilogram. So I'm going to start there at 30 units per kilogram. Okay, now question asks for how many units. That means when I get done here, I just have to have units. The only way to get rid of kilograms would be to involve the patient's weight. So I can cross out those kilograms. We're going to want that 78.18 kilograms on the top. And then we'll go over 1. That's going to let me cross out kilograms and kilograms. If I multiply straight across right there, I'm going to get 2,345.4. We're going to want to round that to 2,345, and then it is going to be units. All right, now for the second, or actually the first part of that question, what is the flow rate that you will set the IV pump at? All right, so we're going to calculate the new flow rate. Okay, so to do that, we're going to have to, we've got this units per kilograms per hour, so we're going to have to involve the patient's weight. So let's go ahead and start with that patient's weight. We'll have the 78.18 kilograms. We'll put that over 1. All right, now what was ordered is the 18 units per kilogram per hour. To be able to get the kilograms to cross out, I need the kilograms per hour across the bottom. So I'm going to multiply by the 18 units on top. And then we've got the kilograms per hour on the bottom. We can go ahead and cross out kilograms and kilograms. All right, now we know this is going to be milliliters per hour. I have hours, but I have units, no milliliters. So the next thing I have to work on is getting rid of this units. All right, the heparin bag had 25,000 units per 500 milliliters. That's going to give me an opportunity to get rid of the units. I'll be left with milliliters. So then units is on top here. I have to have units on bottom here to be able to cross out. So that means I've got to put the 25,000 units on the bottom, and I've got to put the 500 milliliters in the top. That's then going to let me cross off units and units, top and bottom there. As I look at my problem, I've got milliliters across the top, I've got hours across the bottom. Milliliters per hour is what they asked for. So I can take a calculator, I can multiply those numbers across the top. I'm going to get a 703,620, and then the only label on the top there is milliliters. Only number on the bottom there is 25,000, and label is going to be hours. Whoops, is going to be hours. So I'm going to have milliliters per hour here. Take calculator, divide those two out. I'm going to get a 28.1 milliliters per hour. Example 10. Lidocaine 2 grams has been added to 500 milliliters of D5W, dextrose 5% in water. The order states to infuse the lidocaine at 2 milligrams per minute for a patient. The nurse needs to calculate the rate in milliliters per hour at which the IV pump should be set. All right, so again, maybe a lot of information in here. Let's go ahead and do some highlighting here. We've got 2 milligrams that's been added to our 5 milliliters. Okay, so let's do that. Highlight that. All right, the order states to infuse at 2 milligrams per minute. So that's important. So let's highlight that. All right, and then our overall answer here is going to be milliliters per hour. Okay, now it's going to be actually for unit analysis quite a lot of conversion things we're going to have to multiply. We've got milliliters per hour, but yet this is given to us in minutes. So we've got one conversion factor that's going to happen there. Okay, this is grams here. This is milligrams. So I'm going to have to do a conversion there because I've got to get all the way down to milliliters per hour. All right, now using this unit analysis, we can multiply things in any order and it doesn't make any difference. So what I'm going to try to do is I'm going to take the available concentration, which is this 500 milligrams per milliliters, 500 milliliters in 2 grams. I'm going to start with that, convert, then do what's ordered, and then convert again. So that way the labels will be right next to each other and they'll kind of line up. It'll be easy for you to see why and how we're crossing this stuff out. So I'm going to start with my available concentration. That's at 500 milliliters, 2 grams. So I'm going to do 500 milliliters. All right, 2 grams. All right, let's go ahead and label that as our available concentration. Okay, now, first thing I know, I've got to get rid of my grams, okay, and I'm going to get rid of those milligrams too, because I need just milliliters per hour when I get done. So, a conversion factor, hopefully, that you have memorized at this point. If I want grams to disappear, I can convert first grams to milligrams, and then when I use the 2 milligrams per minute, then the milligrams will cross out. So my conversion factor is going to be 1 gram on top so that the grams will cross out there, is equal to 1,000 milligrams. All right, so then that is a conversion factor that you have to have memorized. All right, I'm going to go ahead and cross out grams and grams. Okay, now I'm going to take what was ordered. The order states to infuse that lidocaine at 2 milligrams per minute. Well, now I have milligrams on the bottom. So then that makes sense then to go ahead and put what was ordered next, put our 2 milligrams on the top per minute there on the bottom. So this is what was ordered. And then that's going to let me cross out milligrams on the bottom, milligrams on the top. So now I've gotten rid of all of that. I'm down to milliliters per minute, but I need milliliters per hour. So now I've got one more conversion factor. We got to go from minutes to hours. We know there's 60 minutes in an hour. So I want the 60 minutes on the top, so those minutes are going to cross out. I want the 1 hour on the bottom. So again, this is going to be another conversion factor. Okay, and let's go with yet another color. The minutes here, we'll cross out with the minutes here. Okay, now if you check what you've got milliliters across the top, you have hours across the bottom. So then that's what I want, milliliters per hour. So now I can multiply straight across the top. That's going to be a 60,000. The only label there will be milliliters. Okay, the only thing I got to multiply there on the bottom is that 1,000 times the 2, so I'll have a 2,000. And the only label left is hours. So I got the right hours there. Doing a calculation there of dividing, I will have 30 milliliters per hour. Example 11. A patient with hypotension has a vasopressor ordered at 15 micrograms per minute. The concentration is vasopressor 4 milligrams in 250 milliliters of D5W. How many milliliters per hour should the IV pump be programmed for? All right, so again, this is just going to involve at least 4 things that we have to multiply together. I'm going to start with that available concentration, multiply by a conversion factor, then take what's ordered and multiply by the conversion factor. But again, the order in which you multiply things does not matter. I'm just doing that so that the labels nicely line up and you can easily see why things are getting crossed out, where they're getting crossed out. Okay, so we were ordered 15 micrograms per minute. The concentration is 4 milligrams in 250 milliliters. And again, our answer, milliliters per hour. Okay, so we've got to deal with a difference here of milligrams and micrograms. So that's going to have to be put out, okay? And then minutes here, hours here, so we're going to have to get rid of that and put that out as well. Okay, so let's start with our available concentration. Our available concentration is the 250 milliliters in 4 grams. And I want milliliters per hour, so definitely going to put that milliliters on top. So I'm going to have 250 milliliters over the 4 milligrams. And that is the available concentration. Okay, I'm going to multiply that by a conversion factor. I want milligrams to go away. There is 1 milligram. 1 milligram equals 1,000 micrograms, so that's a conversion factor you're going to have memorized. 1 milligram on top, so those milligrams will cross out. We'll have 1,000 micrograms. So at that point, milligrams and milligrams are gone. So I've got a conversion factor. All right, now for the next thing I'm going to do, if I take a look at what has been ordered is 15 micrograms per minute. Well, I've got a micrograms here and I want to get rid of it. So now I'm going to go to what was ordered. All right, the micrograms needs to be on top so that the labels will cross off. So I'm going to have 15 micrograms per minute, and that is what was ordered. Okay, so on this one, I'll cross off micrograms and micrograms. Okay, now just look at your labels. What have you got? You got milliliters per minute. Not done yet because this is milliliters per hour. So I need another conversion factor. I've got to do minutes to hours. So I know that there are 60 minutes in an hour. So I'm going to put my 60 minutes in the top. I'm going to put the 1 hour in the bottom. That's going to let me cross off my minutes and minutes. Okay, let's go ahead and label this as a conversion factor. All right, now if I go through and I look, I've got milliliters on top. I have hours on the bottom. I need milliliters per hour, which then tells me I am done. I can multiply across the top. I'm going to get 225,000. That'll be milliliters. Okay, multiplying across the bottom, that's going to give me a 4,000. Only label there on the bottom is our hours. You'll go ahead, take a calculator and divide that out. It'll be a 56.25, and then your label will be milliliters per hour. Example 12. A medication order for a client that weighs 80 kilograms states to infuse dobutamine 250 milligrams IV and 250 milliliters D5W at 5 micrograms per kilogram per minute. The infusion pump must be set to how many milliliters per hour? All right, so very, very similar to the previous example. However, now this is micrograms per kilogram per minute, which means we are going to have to use the patient's weight. And in this one, the patient's weight is already in kilograms, so it matches. We don't have to worry about converting the patient's weight. I am going to go through and highlight the important parts here. All right, patient weighs 80 kilograms. We're supposed to infuse that 250 milligrams IV in 250 milliliters. And we've got 5 micrograms per kilogram per minute. And just to remind ourselves what our final answer has to be in, that's milliliters per hour. So basically, those are all the important parts of the story problem. Okay, so again, we're going to start with the available concentration, which is that 250 milligrams in the 250 milliliters. Okay, so what's available? Now, on this one, just because of how many things I know I'm going to have to cross out, I've got to get rid of the milligrams. I got to get down to my micrograms. Micrograms are going to cross out. Kilograms, minutes are going to cross out. So I am going to choose to put the 250 milligrams on the bottom. So I'm going to have 250 milliliters over 250 milligrams. Now, to begin with, you may not catch that and realize that that's what you're going to need to do. The other way to look at that, which would probably be easier than what I just said, I need milliliters per hour. I need milliliters on top for my final answer. Putting that milliliters on the top here will have it there, so when everything else crosses out, it's where it needs to be. So that's a better way of putting it. All right, now this was my available concentration. So we'll label that. Okay, now again, I'm going to choose to multiply by a conversion factor, and I'm going to do one that gets me from milligrams to micrograms. So that is 1 milligram is equal to 1,000 micrograms. And then those milligrams are going to cross off. So milligrams, milligrams, and this is a conversion factor. Now I'm going to take what was ordered. What was ordered here? 5 micrograms per kilogram per minute is what is ordered. All right, so again, I need the micrograms in the top. So I'm going to put the 5 micrograms in the top. I'm going to put both the kilograms and the minutes in the bottom. I need both of those to cross out a little bit later. All right, and then that is what is ordered. So we'll label that as ordered. And then crossing out the micrograms. Okay, now I've got milliliters per kilogram per minute, so I've got to get rid of both those two things. Which one I get rid of first at this point really doesn't make any difference. So let's just go ahead and do our first, our conversion factor for minutes, since we know there's 60 minutes in the hour. Minutes are in the bottom. I want minutes in the top. So we're going to go 60 minutes here. And then that's going to be over 1 hour. Okay, again, that is a conversion factor, so we'll label it conversion factor. And that's going to let me cross off minutes and minutes. All right, so I still have the kilograms. They gave me the patient's weight in kilograms, so that means I've got to include the patient's weight. So this is a problem that definitely involves the patient's weight. So that's going to be 80 kilograms. Again, on top, because the kilograms is on top here, it's on the bottom here. I want those to cross off. We're going to label this just as our patient's weight that we're including, and then crossing off kilograms and kilograms. Okay, now at this point, I think I'm done, so I'm going to go through and I'm going to check. The only label on top is milliliters. The only label on the bottom is hours. Question asks for milliliters per hour, so then that's how you know you are done. Take a calculator, multiply all those numbers across the top. You're going to get 6 million. And the only label there on top is the milliliters. Okay, multiplying the numbers there on the bottom, you're going to get 250,000. And the only label on the bottom is hours. So when I divide that out with the calculator, it's going to come out to be 24 milliliters per hour. Example 13. A patient receiving this 15 milliliters per hour. The concentration is 900 milligrams and 250 milliliters. Calculate milligrams per minute. Okay, so we haven't done a milligrams per minute. All right, but if you look at the two things, what the patient's receiving and what the concentration is, available concentration, you got some milliliters. So this time our milliliters is what's going to have to cross out. We got to get down to just having the milligrams per minute. Okay, so let's go ahead and highlight. We've got the 15 milliliters per hour. The concentration is 900 milligrams in 250 milliliters. And let's go ahead and highlight what we need to find, milligrams per minute. Okay, so I'm going to start with my available concentration. That's 900 milligrams in 250 milliliters. So I'm going to have 900 milligrams, 250 milliliters, and that is my available concentration. All right, now I know I've got to get rid of those milliliters. All right, if I take a look at what has been ordered, it has milliliters. I've got milliliters here. So this time I'm going to choose to put the next thing I multiply as being what was ordered. So we're going to do 15 milliliters on top. So the milliliters cross out, and then that'll be per hour. Okay, that was what was ordered. So we'll label that as ordered. Okay, now if I look at what I've got here, I've got milligrams per hour, so really close. I need milligrams per minute. So the last thing is just a conversion factor of hours to minutes. So then I'm going to multiply by, again, I want hours to cross out, so I'm going to put the 1 hour on the top. I'm going to put the 60 minutes on the bottom. Okay, that's going to be my conversion factor. And then I'm going to be able to cross out my hours and hours. And then checking to see if I'm done. I just look to see what label I got on top, milligrams. What label do I have in the bottom? Minutes, milligrams per minute. That's what I need. So then now I know I'm done. Multiplying across the top, I'm going to have 13,500. That's going to be milligrams. Multiplying across the bottom, I'll have 15,000 minutes is going to be my label. That's okay that the top number is smaller than the bottom number. You're just going to go ahead and divide. You'll end up with a number less than 1, 0.9, and that's going to be milligrams per minute. Example 14. A patient with heart failure has nitroglycerin infusing at 3 milliliters per hour. The nitroglycerin concentration is 100 milligrams in 500 milliliters of D5W. At what rate in micrograms per minute is the nitroglycerin infusing? Okay, so again, my question is asking for micrograms per minute. All right, now if I go up and I look at everything that they have given me, my available concentration is 100 milligrams in 500 milliliters. So neither one of these two labels I need in my answer. So I'm going to have to get rid of both of those labels. All right, if I look at what was ordered, 3 milliliters per hour. So again, milliliters an hour, I'm going to have to get rid of those labels as well. So for that reason, it doesn't matter which one of those two I start with. I can start with the available concentration. I can start with what's ordered, because all of those labels that I was originally given, all 4 of those labels have to go away, because I've got to get down to micrograms per minute. All right, so since it really doesn't matter what I start with, I'm going to go ahead and start with the available concentration, because that's the way I've been doing most of these. Okay, so 100 milligrams in 500 milliliters. So I'm going to go 100 milligrams on top. I'm going to put 500 milliliters on the bottom, and this was my available concentration. Okay, then I'm going to choose to multiply by a conversion factor. All right, I've got milligrams, I got to go to micrograms. So 1 milligram is equal to 1,000 micrograms. You have to have that memorized. My milligrams need to cross off. I'm going to go ahead and put that 1 milligram in the bottom. I'll put the 1,000 micrograms in the top. Okay, that's a conversion factor, one that you have to have memorized. Okay, that's going to allow me to cross off milligrams and milligrams. Okay, now at this point, I think I'm going to go ahead and do what is ordered, because I have a milliliters in the bottom, and what was ordered is 3 milliliters per hour. So if I multiply by this, I can get rid of those milliliters. So then I'm going to put the 3 milliliters on top, and then per hour on the bottom. This is what was ordered. And then, even though they're not next to each other, they don't have to be next to each other. Anything in the bottom compared to anything in the top will cross out. So my milliliters are on the bottom here, milliliters are on the top here, okay? They do not have to be next to each other to cross out, so I can go ahead and cross those out. Now I've got micrograms per hour. I need micrograms per minute. So I need another conversion factor, minutes to hours. Whoops, that should be a time sign. Minutes to hours, so hours have to cross out, so that means I've got to put the 1 hour on the top. I got to put the 60 minutes on the bottom. So that's going to be the last conversion factor that I need. So conversion factor. And then that allows me to cross off the hours on the bottom here and the hours on the top here. Now, just to go back and check, I'm supposed to have milligrams per minute across the top. I'm sorry, micrograms per minute across the top, micrograms per minute on the bottom. Only label left is minutes. So then that tells me I am done. I'm going to multiply across the top there. I'm going to have 300,000 across the top. That'll be milliliters. Nope, that's going to be not milliliters. What label do I have left? Micrograms. So that's going to be micrograms. And then across the bottom, I'll have 30,000. And that's going to be minutes. There we go, micrograms per minute. I'll go ahead and divide that out. I'm going to have 10 micrograms per minute. All right, our last example, example 15. A patient is admitted to the ICU with dopamine infusing at 13.5 milliliters per hour. The patient's weight is 75 kilograms. The dopamine concentration is 1 gram in 250 milliliters of D5W. At what rate in micrograms per kilogram per minute is the dopamine infusing? Okay, so this is the first one that we have done like this. We are calculating as a final answer micrograms per kilogram per minute. Okay, now let's go ahead and highlight the other important parts because we had a lot in this story problem. All right, so he's a patient's admitted with dopamine infusing at 13.5 milliliters per hour. The patient's weight is 75 kilograms, so that's important. The concentration is 1 gram in 250 milliliters. Okay, so again, we do have kilograms in our final answer, so kilograms, that's good. That means we're going to have to include the patient's weight. Micrograms, all right, well, we don't have micrograms. We have grams, so there's going to be a conversion there. All right, this is per hour, and this is per minute. And we also have milliliters here. So our milliliters and milliliters here is going to ultimately get crossed out because I don't need milliliters in my answer at all. All right, so again, you can multiply these conversion factors that you need and what's available in the story problem in any order. So I'm just going to kind of stay with what I've been doing. I've been starting with that available concentration. Okay, so our available concentration is 1 gram in 250 milliliters. All right, I don't need grams and I don't need milliliters in my final answer. Okay, so both of those are going to get crossed out. So I'm just going to go ahead and go left to right, top to bottom. So I'm going to have 1 gram. I'm going to have 250 milliliters. Okay, that is my available concentration. Okay, now what I'm going to do next is I'm going to choose to multiply by a conversion factor. I know I've got to get my grams down to micrograms. So again, you have to have this one memorized. 1 gram is 1,000 milligrams. Then I'll go from milligrams to micrograms. So 1 gram. And then I'll have 1,000 milligrams. All right, not exactly where I need to be yet, but it is moving in the right direction. So we've got a conversion factor here. That's going to allow me to cross out my grams and my grams. I'm 2 milligrams so far. Now, if I take a look at, actually, I think I want to go ahead and do the second conversion here to get this milligrams all the way to micrograms. All right, so there is 1 milligram in 1,000 micrograms. Again, you have to have that one memorized, but I want milligrams to cross out, so I'm going to put the 1 milligram in the bottom. I'm going to put the 1,000 micrograms in the top. All right, now let's go ahead and write that as a conversion factor as well. And then I chose to do that as 2, okay, but it just depends on what you have memorized as to how you would want to do that. 1 gram is also 1 million micrograms. So instead of multiplying by 1,000, multiplying by 1,000, you could multiply by 1,000,000 there, cross it out. So these two things could be put together in one conversion factor. All right, but separately works just fine. Okay, now I've got micrograms and milliliters. So the next thing to do probably here would be to use what is ordered. That's going to make my milliliters fall out. So I'm going to multiply by, I need the milliliters in the top since it's in the bottom here. So 13.5 milliliters per hour. And that is what is ordered. Okay, so from there I can cross out milliliters and milliliters. So now I'm down to micrograms per hour. I need micrograms per kilograms per minute. Okay, so at this point, I probably am going to go 60 hours. Let's get that converted to minutes. So 60 minutes in an hour. So I want that 1 hour to be on top. I need the 60 minutes in the bottom. Okay, that's going to let me cross off the hours and hours. And now the only thing that's not included is my weight. Let's go ahead and label this conversion factor before I deal with the weight. Okay, but if you stopped now, you would have micrograms per minute, but that's not what the question asked for. Micrograms per kilogram per minute. All right, I am going to want the kilograms on the bottom here, so I'm going to multiply by 1 over the patient's weight, which we said was 75 kilograms. Okay, so this is your patient's weight. Okay, now micrograms per kilogram per minute. I've got all the right labels. Everything else has been crossed out. I know I'm done. Multiplying across the top, multiplying across the bottom. Okay, so let's come down here. Multiplying all those numbers across the top. I'm going to have 13,500,000. And the only label is micrograms. Multiplying the numbers on the bottom will be 1,125,000. Only label there on the bottom is 2 of them, kilograms per minute. So then when you divide those 2 things out, I'm going to get 12 micrograms per kilogram per minute.